Good afternoon, all of you. In this session, we are going to discuss about chemical equations. It is a part of 10th class chemistry. So now we are going to frame the YouTube lectures on different topics covering all the 10th class chemistry topics. Among all, today we are going to choose the topic called chemical equations. It is the chapter 2 in 10th class state syllabus. Now let us go. What is meant by chemical equation? Chemical equation is nothing but whenever any chemical reaction is carried, conversion of reactant species into products are possible. Reactants, when converted into products, they are systematically represented in their chemical formulas. How many number of chemical reactants are combining? What is their stoichiometric ratio? And how many products are generating? What are the conditions we are applying in the reaction? What is the physical state of starting material? And what are the formed product physical state? Is there any heat evolved or absorbed during the chemical reaction? These kind of parameters can be well visualized by the equation called a chemical equation. Within the single line, we can represent entire information about how the reactants get converted into products. That is well explained by chemical equations. Now, let us see what is the introduction for these chemical equations. So many natural process and also some man-made operations are possible around us. We can notice so many type of chemical reactions which are carrying in our day-to-day life. Let us assume how the digestion process is possible. What kind of transformations are possible in that? What happens whenever we are taking food materials? They are composed of various carbohydrates, proteins, lipids, and also so many kind of vitamins and bioorganisms will be there. That will be used to nurture our body and also give the energy for all our metabolic activities. So that digestion process carried in the presence of so many digestive juices secreted in the gastrointestinal tract. Okay, so that can be well visualized by this chemical equation. And next is about burning of crackers. When we are taking crackers, they get subjected to fire so that combustion will be carried in the presence of oxygen and they get converted into oxides by releasing excessive amount of heat energy outside. It is the process of exothermic and we can represent them also in the sequential chemical equation. And next is about process of respiration. Respiration stands for inhalation and exhalation simultaneously. Whenever air is consumed by these lungs, which are carrying all these activities of exchange of gases, so by this respiration, we are adding oxygen into our body so that oxygen will be circulated throughout the body and will combust the food materials, whatever we are taking by that process called digestion, and they get fragmented in the presence of oxygen and energy liberation is possible, right? So for that purpose, oxygen is required and it will be utilized by each and every cell organism, and that oxygen transportation is carried by blood circulation system, and whatever carbon dioxide generated within those organisms can be back transmitted to lungs and exhaled back. So this entire process is reversible, can be represented in the sequential chemical equation form. And the next is about powdered lime added to water. Whenever lime was taken, it is a calcium oxide. This added to water, calcium oxide now subjected to hydrolysis, calcium hydroxide will be generated. This calcium hydroxide is a how this calcium oxide converted into calcium hydroxide, that transformation we also represent in the form of chemical equation. It is a kind of synthetic method. It is not the natural process. We are adding water to that one. And ripening of mango. Whenever mango was taken, it is in green in color initially. What happens slowly? Because of enzymatic transformations, it get converted into yellow color. So this is called ripening. So many chemical reactions are carried in this, which also represented in the form of chemical equation. So many natural and man-made synthetic examples are available around us in order to represent chemical equations. Now, let us go activity 1. So in order to explain activity 1, let us take a tab here. Just wait. So activity 1, which is the part of this representation of chemical equation. So in order to represent that chemical equation, we are taking the example of quicklime. That quicklime subjected to hydration means addition of water. When water is added to quicklime, what happens? Water is added to quicklime and taking in a beaker. So after adding water, we are inserting our finger into that. What you can notice, what kind of changes are possible, that is well explained in this activity number 1. Now, let us move on to the step where we can represent that equation in a clear manner. Just you can see, you can observe what is that activity, right? Here the activity is, we are taking a beaker. This beaker is filled up to certain extent by 10 ml of water. Here 10 ml of water filled into this beaker. To this 10 ml, only how much extent? 1 gram of quicklime is added. Quicklime stands for calcium oxide. 1 gram of quicklime when added to this 10 ml of water, what will be the transformation? What will be the chemical change? Let us see. Calcium oxide plus water gives rise to calcium hydroxide. This is the possibility. Calcium oxide is indicated as CaO, right? Calcium oxide. Water is H2O. Now the formed product will be, here the compulsory condition is whatever the number of atoms present in the reactant, that should be exactly equals to product formed, because energy and number of atoms neither destroyed nor be created. So here 1 calcium is there, 1 calcium is there. Oxygen atoms are 2, here also oxygen atoms are 2 we have. Here 2 hydrogens are there, here also you can find 2 hydrogen atoms. This is about the chemical equation representation for this activity number 1. What we are doing? We are taking a beaker, 10 ml of water is added, 1 gram of calcium oxide is added to this beaker. Now, when 1 gram of calcium oxide added, you can observe heat released during the reaction. Heat is evolved. So, in this process, heat released in the beaker, so that whenever you touch this beaker, what happens? You can notice the liquid is in very high temperature condition, because during the formation of calcium hydroxide, some extent of heat evolved. So that heat evolved, hence you can say the process is called exothermic. Based on heat transformations, you can classify the reactions into 2 types. One is called exothermic. Reaction, and the second is called endothermic reaction. Whenever heat evolved within the process is called exothermic. When heat absorbed within the reaction is called endothermic. During the formation of calcium hydroxide, heat is liberated. That is called the exothermic reaction. When we are taking ice and added with heat, now it is converted into water. In this transformation of ice into water, heat is absorbed. Heat needed for the conversion of ice into water. Hence, you can say this is a process of endothermic reaction, right? So, in this activity 1, what we can observe? there is a possibility of chemical reaction between calcium oxide and water, and that can be represented in this equation form. Calcium hydroxide will be formed. Along with this, some amount of heat evolved in this. Hence, you can say the reaction is exothermic, right? Let us move on to our topic again. Right. In this, activity 1 is completed. Now, let us move on to activity number 2. So, let us explain this activity number 2. We are taking two different beakers. One beaker, 100 ml water was taken and added with sodium sulfate salt into that. When sodium sulfate salt is added to a beaker of water, it is easily soluble. It dissolved in that, completely ionized. Now, another beaker was taken and 100 ml water was poured into that. In that 100 ml water, barium chloride was dissolved. Barium chloride was dissolved in the second beaker. One beaker having sodium sulfate water, second beaker have barium chloride water. When both get mixed, both are colorless initially. But when both solutions get mixed, you can observe one white color precipitate formation. Then let us see what is the reason for that white color solution formation. So let us explain that using again pen tab here. Right. So this is the activity 2. Activity 2 was taken. In order to explain this activity 2, we are taking two beakers. Beaker 1 is added with 100 ml water first. To this 100 ml water, we are adding sodium sulfate. Sodium sulfate dissolved in this. It is easily soluble in water because it is a water soluble substance. We are taking another beaker. In this beaker, 100 ml water taken first. 100 ml water. To this 100 ml water, it is added with barium chloride. This barium chloride also water soluble. Here, the solution is colorless in beaker 1. In beaker 2, also solution is colorless. Both the solutions are colorless. What we are doing? We are mixing these two beakers. Whenever these two beakers get mixed, what happens? At the bottom, you can observe one white precipitate. One white precipitate is formed. This is the activity we are doing in this activity number 2. Taking a beaker added with sodium sulfate, taking another beaker added with barium chloride. When these two solutions get mixed, you can notice white color precipitate at the bottom. This is because when sodium sulfate added to water, it easily ionized into corresponding ions. Sodium ionized into Na plus. How many sodiums are there? 2 sodiums. That's why 2 Na plus will be formed. And remaining sulfate is converted into SO4 minus 2. This is the ionization of sodium salt when added to water. And next is about barium chloride. When barium chloride added to water, barium is converted into barium plus 2. Chlorine is converted into chlorine minus. Everybody know valencies of barium and chlorine. Barium is dipositive ion, 2 plus 2 charge will be there on this. Chloride is minus charged ion. How many chlorines are there? 2 chlorines. That's why 2 Cl minus will be formed. When these two are mixed, what happens? Now, barium is added with sulfate. It is converted into It is converted into right. It is converted into barium sulfate. This barium mixed with sulfate, there is a formation of barium sulfate plus here 2 Na plus 2 Cl minus are there. They are converted into 2 NaCl. Okay. So barium sulfate and 2 NaCl formed. This barium sulfate is white color precipitate, whatever formed in the beaker. Here you observe that white precipitate is formed. That white precipitate is nothing but barium sulfate, which is formed by mixing Na2SO4 with BaCl2. And in this beaker, you also find another solution, that is sodium chloride, because in this another product is also formed by mixing Na plus with Cl minus, but it is water soluble. Water soluble. That's why no precipitate will be formed here. In this way, the second activity will be carried. Okay. So here you can observe a precipitate formation at the bottom, right? So let us move on to our actual topic. Here, 100 ml of water added with sodium sulfate, another 100 ml of water added with barium chloride. So there is a formation of barium sulfate and sodium chloride by mixing these two, because they are exchanging ions. That's the reason why you can notice a white color precipitate which is formed because of barium sulfate formation. Okay, do you observe any changes in this? Yes, initially colorless. After mixing, they converted into white color precipitate. Now let us move on to activity number 3. How the activity number 3 will be performed? By taking a conical flask. This is called the glass apparatus, which is used for the titration actually in the volumetric analysis. This is called conical flask, which is also called as Wills-Meyer-Hack flask. In this, we are taking zinc granules. Small zinc pieces will be taken. To this small zinc pieces called granules, now we are adding dilute hydrochloric acid. When dilute hydrochloric acid added to zinc, there is the possibility to liberate hydrogen gas. Hydrogen will be evolved during the reaction. When hydrogen gas is evolved, you can test this liberation of hydrogen by keeping a matchstick on this, burning matchstick on this, the mouth of the conical. Whenever this burning matchstick placed on the top, what happens? That burning will become bright because hydrogen will facilitate that burning tendency. So based on this, what we can observe, whenever any metal added with acid, there is a formation of hydrogen gas is possible. Then how can we represent this activity in the form of equation? Let us see how it can be represented in the form of equation. We will go with that explanation part. Let us go on to explanation part. Where we are taking a conical flask here. This is the conical flask. We are taking zinc granules, small pieces of zinc inserted within this conical. Small pieces of zinc inserted in this conical. Now we are pouring dilute hydrochloric acid. Dilute hydrochloric acid is added. Dilute hydrochloric acid in the sense hydrochloric acid mixed with water is called a dilute hydrochloric acid. When these two added, what is the possible reaction? Let us see. Zinc plus HCl. Formed product will be ZnCl2. ZnCl2 plus H2 formation is possible. Zinc with HCl gives ZnCl2 and leftover hydrogen is converted into hydrogen gas. Then how can we represent this equation in the balanced form? This is a possibility. But balanced equation we have to write. Balanced equation in the sense left side terms, right side terms should be equal. One zinc is there, here also one zinc is there. Here H1 is there, but here H2 is there. Here Cl1 is there, but here Cl2 is there. That's why equation not in the balanced state. How can we write balanced equation? Zinc plus 2HCl gives rise to ZnCl plus H2 formation is possible. One zinc, here also one zinc. Here 2 chloride ions are there. Here you have to insert Cl2, ZnCl2 it will be, right? And 2 H hydrogens are there. It is indicated as H2. 2 hydrogens indicated as H2. Now this is called the balanced equation. Balanced equation. And during the reaction, hydrogen is a gas. That's why it will be liberated out. So it is coming out, that's why indicated with upside arrow. If it is formed at the bottom, you have to indicate downside arrow. If it is precipitate, you have to indicate downside arrow, it will be precipitated. But in this reaction, hydrogen is coming out, evolved. Hence, we can say it is indicated with upward arrow. So, the balanced equation is zinc plus 2HCl gives rise to ZnCl2 plus hydrogen which evolved out. This is the complete information about this activity. During this reaction, hydrogen gas is evolved. Here, hydrogen is liberated out. How can we notice? By taking matchstick, which is burning already. So when placed here, you can observe glorious flame on its surface. It is burning with high brightness, right? So this is the activity, what you can observe in this activity, right? So what kind of chemical change? Initially, zinc is in solid metallic state. After the reaction, it is converted into zinc chloride state. Combined form will be generated. So this is activity number 3. Now, what are the guidelines or protocols in order to write this chemical equation? What kind of steps are required in order to write the chemical equation? First, let us see. In the activity number 1, what we are taking? We are taking calcium oxide. Calcium oxide is added with water. When we go to back activity number 1. Activity number 1, calcium oxide was taken. This calcium oxide 1 gram is added with 10 ml of water, right? Now, whenever it is added to water, that dipped with litmus paper. So that litmus paper initially red in color, it is turned into blue color. That indicates base formed within the reaction mixture. Whatever solution is generated is basic in nature. How can you predict? By using litmus test. Litmus test says that red turned into blue is called base. Blue turned into red is called acid. Now, red to blue transformation is possible. Hence, you can say we have calcium hydroxide in that beaker. That is a basic substance. Now, it is indicated in a sequential order called calcium oxide plus water gives rise to calcium hydroxide. Calcium oxide added to water, calcium hydroxide is formed. Now, the terms which are used in left-hand side are called reactants. Reactants means which are reacting themselves, which are involved in the chemical reaction. Hence, you can say these are the reactants. Whatever compound generated, produced in the reaction is called product. Calcium oxide water gives rise to calcium hydroxide. This calcium hydroxide is the product in this reaction. So this is about the chemical equation what you can write. Arrow indicates in which direction reaction is moving. Left to right hand side reaction is moving. That's why arrow is used. And one more time, if we are having more than one reactant, here this is calcium oxide is one of the reactant. Water is also another reactant. They get mixed by the term called plus. Plus indicates joining two different reactants so that here product is generated. Arrow indicates the direction of reaction. If it is in moving in left to right, you have to indicate forward arrow. If this is converted into the calcium oxide and water, we have to indicate in the reverse manner. But reaction is proceeding in the forward manner. That's why arrow is towards calcium hydroxide, right? So this is about the typical representation of chemical equation. Now, let us see what are the some guidelines, some rules in order to write chemical equation. How can we write the chemical equation? Let us see. So always writing all these calcium oxide, water, calcium hydroxide names are very lengthy. It's very difficult to write always. That's why instead of names, we can go with any other alternative method in order to represent the chemical equation. That is chemical formula. Calcium oxide is indicated as CaO. This is one of the reactant. Plus water. Water is represented as H2O. When these two get mixed, product is formed. What is the product? Calcium hydroxide. Okay, calcium oxide plus water gives rise to calcium hydroxide. This is a way of representation of chemical equation. Now let us move on to any other activity, that is activity number 3. What is activity number 3? Let's go back. In activity number 3, hydrogen added with HCl, hydrogen plus zinc chloride is formed. Now let us see how it will be represented in the equation form, how it will be in the chemical equation form. Zinc is a metal added with hydrochloric acid, formation of zinc chloride salt is possible. Along with this, H2 will be liberated, hydrogen gas is liberated. But when you observe clearly, equation is not balanced. Here one hydrogen, here two hydrogens, here one chlorine, two chlorine. That's why we have to put 2 HCl here. Now, let us move on to another question, that is activity number 2. Sodium sulfate mixed with barium chloride, formation of barium sulfate plus sodium chloride is possible. Internal exchange. Among the two different species, we are exchanging one of the ion with another. So barium sulfate plus sodium chloride will be formed. This is about the representation of chemical equation in terms of their chemical formula. Now, till this you learned how reactants combine product form. But now the next parameter is how can we balance the equation? Balancing the equation is nothing but how reactants converted into product without changing number. If you are taking one zinc, even in the product also one zinc atom should be there. If you are taking two hydrogens initially, product should give two hydrogens. That is nothing but balancing the equation. In order to balance the equation, first we have to write a chemical equation. I'm taking a simplest example. Hydrogen gas mixed with oxygen gas, formation of water is possible. In general, hydrogen oxygen get mixed, formation of water is possible. But here equation is not in the balanced state. Two hydrogens, two oxygens, two hydrogen, one oxygen product is there. Step 2, we have to balance this. How can we balance this? Let us see. Here, 2 hydrogens plus O2 gives rise to 2H2O we are indicating. Whenever 2 hydrogens are taken, total hydrogens are 4 in this. Here we have 4 hydrogens and 2 oxygens. Here 2 oxygens. So equation is in balanced state now. This equation is balanced now. So now step 3. What we have to take step 3? Sometimes possibility of coefficient of substances getting divided with suitable numbers, since we require lowest ratio. So for example, we may take 4H2, 2O2, 4H2O is also possible. I'm taking one of the example. So let us practice in the whiteboard. Let us practice in the whiteboard. Right. Here I'm taking, so coefficient should be in the minimum. Coefficient should be minimum in the sense I'm taking hydrogen plus oxygen gives rise to H2O. This is the first step of writing chemical equation where chemical formulas of atoms should be taken. Chemical formula of hydrogen is H2. Chemical formula of O2 is oxygen is O2. Chemical formula of water will be H2O. Now, second step, balancing the equation means atoms in left side, right side should be same. For that purpose, what we have to do? 2H2 plus O2 gives rise to 2H2O. 4 hydrogens, 2 oxygens are there. So it is in balanced state. In third step, coefficients should be minimum. Coefficient should be minimum is the third rule, third ground rule. Let us see how it is possible. Same equation can be represented in any other balanced form also. If I take 4 hydrogens, it needs 2 oxygens and there is a formation of 4H2O is possible. Let us see balanced or not. 8 hydrogens, 8 hydrogens. 4 oxygens, 4 oxygens. That's why here also equation balanced, but it should be lowest coefficient. Coefficient should be minimum. Means can we cancel all these terms with a minimum term? 2 2s, 2 1s, 2 2s. Means it can be represented as a lower coefficient like 2H2, 1O2 gives rise to 2H2O. This is the minimum coefficient for this equation. Means it is the correct form of representation. This is 1 not 10, 1 only, right? So this is a right representation, but not 4H2, 2O2, 4H2O. So these are the maximum coefficient. This is not required. Only minimum coefficient should be preferred if we are taking a balanced chemical equation. This is the third ground rule. Now let us move on to fourth. Verify equation for balancing atom both sides in the equation. Above equation is balanced. So whether left side, right side atoms are in the equal number or not, we have to balance by using number of atoms in the left and right hand side. Let us go with one simplest example, combustion of propane. When propane is combusted, what kind of possibility we have? Let us see. So let us go to whiteboard again. Let us move on to here. We are taking propane. Propane is CH3, CH2, CH3. This is called propane. This can be represented in simple formula. How many carbons? 1, 2, 3 carbons are there. See, 3. Hydrogens, 3, 5, 8. Hydrogens are 8. This is called propane. Propane molecular formula. Now we are adding oxygen. What will be formed? Carbon with oxygen formation of carbon dioxide. Hydrogen with oxygen forms H2O. This is the step 1. What step 1 represent? What are the chemical species interacting that should be represented? One is propane. Second is oxygen molecule. Third is carbon dioxide. Third is carbon dioxide. Fourth is water. These are the possible reactants and the products in this reaction. Step 2 represents what? Step 2 represents what? Balancing the equation. How can we balance? C3H8 plus O2 gives rise to CO2 plus H2O. How many carbons are there? Sorry. It will be C3 H8. How many carbons are there? 3 carbons are there. Here, how many are there? Only 1. So we have to incorporate 3. 3 CO2 plus H2O. How many hydrogens are there in this? 8. So here 2 are there. So in order to get 8 hydrogens, here we have to put 4. Now let us see C8. Sorry, it is not C8. C3H8 plus O2 gives rise to 3 CO2 plus 4 H2O. Whether equation balanced or not, let us check. C3, 3 CO2 here. 3 CO2 will be formed. C3 carbons are 3. Here also carbons are 3. Now hydrogens are 8. Here 4 2s are 8. 8 hydrogens are there. Let us check with oxygens whether oxygens balanced or not. Here O2 means 2 oxygens are there. Here 3 2s are 6 oxygens. Here 4 oxygens. Total how many oxygens are there? 10 oxygens are there in the product. But in the reactant we have only 2 oxygens. How can we balance 10 oxygens? Here we have to put 5 O2. C3H8 plus 5 O2 gives rise to 3 CO2 plus 4 H2O. Let us write the complete equation. C3H8. This is called propane. What is the name of compound? Propane. Now it is treated with 5 moles of molecular oxygen. What is this? Oxygen. Then what will be formed? 3 molecules of carbon dioxide and 3 molecules of carbon dioxide and 4 molecules of water will be formed. This is the balanced equation for combustion of propane. Propane will be combusted in this manner. Let us move on to our book. C3H8O to CO2 plus water. This is the normal elementary equation. By balancing, what happens? 3 carbons are there. That's why we have to put 3 CO2. Then hydrogens are 8. Let us put 4 H2O. Then C3H8 requires 5 O2. Then only 3 CO2 and 4 H2O formed. This is a completely balanced equation. Okay. So it can be represented in any other terms also. It can be represented in any other terms also. How can we represent? Let us see. So by taking doubling of all the reactants and products, it can be represented as, let us write. Let us write. And what we can write? Actual equation is C3H8 plus O2 gives rise to CO2 plus H2O. How can we balance? C3, that's why it becomes 3 CO2. H8, it becomes 4 H2O. So total 10 oxygens are there. That's why 5 into O2, it will become 10 O2, right? So this is the complete balanced equation. It can be represented in either form also. 2 moles of C3H8 can be added with 10 moles of O2, gives rise to 6 moles of carbon dioxide and 8 moles of H2O. So this is doubling the all coefficients. Is it correct representation? Or first one is the correct representation? This one or this one? Which is the correct representation? The equation should be in the balanced form with the equation should be in the balanced form with the minimum value of coefficients. Minimum value of coefficients. Minimum value of coefficient should be there. Means C3H8 plus 5O2 gives rise to 3 CO2 plus 4 H2O. This is the exact representation of combustion of propane. with the oxygen, but not second one, right? So this is not the correct representation. So these are the steps involved in balancing the equation. So in this way, we can write steps involved in balancing the equation. Let us move on to another reaction. It is also very interesting. That is iron oxide, now treated with metallic aluminium. Formation of iron plus Al2O3 is possible. So in this, we have to balance their coefficients and also balance their number of atoms present in this. We are taking iron oxide. Iron oxide is Fe2O3. Now added with aluminium metal. What happens? Aluminium is converted into aluminium oxide. Now iron is converted into Fe. So in this, how can we balance the equation? How can we balance the equation? Let us see. Again, we are going to whiteboard. Let us take new one. It is represented. How this equation is possible, let us see. Here, another example for balancing the equation, right? We are going to write chemical equation between iron oxide and metallic aluminium. These two are the reactants. Products will be iron and aluminium oxide. Aluminium oxide. So by taking this reaction as the reference, we have to predict how to write the balanced equation. These are called reactants and these are called products, right? Reactants and products were mentioned. Now let us go with iron oxide. Iron oxide formula is Fe2O3. It is treated with metallic aluminium. Now what will be the product? Metallic iron plus aluminium oxide, that is Al2O3, right? This is called step 1. What is step 1? Just writing skeletal equation without balancing. Directly we have to write iron oxide means iron oxide, aluminium, aluminium, metallic iron, aluminium oxide, Al2O3, indicated like this. Now we have to balance. In step 2, what we will do? How many irons are there? 2 irons. How many irons are formed? 1 iron. Now let us balance iron atoms in this equation. Here 2 irons are there. That's why here 2 Fe plus Al2O3 is formed. Step 2, balancing iron completed. Now let us go to balancing aluminium. Fe2O3 plus. Here you can find 2 aluminium. Here only 1 aluminium is there. That's why we can indicate 2 Al gives rise to 2 Fe plus Al2O3. Now let us check. 2 Fe, 2 Fe, O3, O3, 2 Al, 2 Al means now the equation is in completely balanced state. I'm giving one more equation for this. 2 Fe2O3 plus 4 Al gives rise to 4 Fe plus 2 Al2O3. This is also balanced equation. Only by doubling their coefficient it will be obtained. This is also balanced. Now let us predict which is the exact representation of balanced equation, balanced chemical equation among these two. Where minimum coefficients are present, that is the actual requirement. That's why this 0.4 will be the exact representation of chemical equation for iron oxide on treating with aluminium. Iron plus aluminium oxide formation is possible, right? So this is the another example for balancing equation. Now let us move on to our problem. Right, so in this way, representation Fe2O3 plus 2Al gives rise to 2Fe plus Al2O3. This is a finalized equation. Now more meaningful equation is represented by substituting some other terms. So to make the complete information within the single reaction, so we have to incorporate some other new terms in that equation. One is representing their physical state, means whether it is solid, liquid or gaseous substance. That representation is required. So by using that, we can identify whether it is solid, liquid or gaseous substance. And the second is heat change of the reaction, whether heat absorbed or released within the reaction also. Gas evolved any or any other precipitate formed. This can be explained in the chemical reaction. Yes. Making chemical reaction more informative, it is possible to represent their physical state like solids, liquids, and gaseous substances. And also it is possible to represent their heat changes, whether heat absorbed or heat released during the reaction, whether gas evolved or absorbed, any precipitate is formed within the reaction, and we are providing heat to the system or not. All the things can be represented within the single reaction. Now, let us see same reaction. Just now we balanced ferric oxide Fe2O3 with 2 aluminium. Upon heating, these two get mixed and subjected to rising temperature, subjected to heating. There is a formation of 2 iron plus Al2O3, right? Now, let us explain on the screen. So this is the possible reaction we already saw, right? So in this reaction, what is the possibility? Let us write equation one more time. So here Fe2O3, let us write in the more meaningful form just mentioned in this. What is the nature of this Fe2O3? It is the solid substance and it can be treated with metallic aluminium. It is also solid substance. There is a formation of iron, so again solid, and formation of Al2O3 is possible, again solid substance. Here 2Al required, 2Fe formation is possible. In order to mix these two, we have to heat this. It is represented with this delta. Delta represent heating these two substances. Heat is provided. Endothermic reaction. It is a kind of endothermic reaction. Endothermic reaction. So this will give more meaning to the equation. Fe2O3 solid, aluminium solid, iron solid, and Al2O3 solid formation is possible within the reaction, right? All are in solid state only. And this is the aluminium metal which exists in solid lustrous form. And iron is also, everybody know iron rods, iron steels, building construction material, and also iron machinery. So all are having solid nature, right? So this is also in either form, right? So here are some other examples which used to represent heat of the reaction, which are used to represent heat of the reaction. Now let us see how it is represented. Okay, carbon on combustion gives rise to carbon dioxide. Carbon on reaction with oxygen gives rise to carbon dioxide. In this reaction, heat is coming out. Heat is evolved in the reaction, that is called exothermic reaction, right? Nitrogen plus oxygen, there is a formation of nitrogen dioxide, right? That carbon plus oxygen gives rise to carbon dioxide, and there is a formation of carbon dioxide, and heat is liberated within the reaction, which is called exothermic. When we are taking nitrogen and added with oxygen, So this nitrogen added to oxygen, formation of nitric oxide, where heat is required, means heat is absorbed for this formation. This is called endothermic reaction, denoted with minus sign because heat required. We have to give the heat from the outside. Hence it is called exothermic. So let us write these two equations. Let us write these two equations in this. Let us write on the whiteboard. Right. What we will do? So I'm taking carbon and treated with oxygen. Formation of carbon with oxygen, formation of carbon dioxide is possible. Everybody know carbon is a solid material. You may take coal, you may take coke, all those are the forms of carbon only. Graphite, diamond is also carbon, right? Oxygen is a gaseous substance. It is the gaseous substance, and there is the formation of carbon dioxide. Gas is possible. Carbon plus oxygen gives rise to carbon dioxide. Solid, gas formation is possible. In this reaction, when they combusted along with the product, some amount of heat is evolved. Heat is evolved. When heat liberated in the reaction is called exothermic. Heat liberated in the reaction is called exothermic. Nitrogen on treating with oxygen, formation of nitric oxide. This is called nitric oxide. This equation is in balanced state now. N2 plus O2 gives rise to 2NO. In this reaction, minus Q is represented. What does it mean? Heat absorbed. Heat absorbed in the reaction. Hence, it is called endothermic reaction where heat absorbed. Heat is taken inside, that is called endothermic reaction, right? So in this way, heat of the reaction is also mentioned within the chemical reaction, right? Then expressing gas evolved during the reaction. So whenever gas evolved during the reaction, that also represented in this. So how can we represent? Let us see. How can we represent gas evolved in the reaction? Let us see. Sorry. Gas evolved in the reaction can be represented as, right? So we are taking zinc metal and treated with sulfuric acid. Either you can take sulfuric acid or HCl, any acid can be treated. Formation of zinc sulfate and liberation of hydrogen gas is possible. What is the nature of zinc? It is the solid. This is a representation of its physical state. Sulfuric acid is the liquid. L stands for liquid. Zinc sulfate solid will be formed and hydrogen gas evolved coming out, which is represented with upward arrow, right? This is the complete representation of the equation. Zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen, where upper arrow indicates hydrogen gas is liberated from this reaction. So this is about upside arrow. Upside arrow is represented. Okay. So now let us see silver nitrate treated with sodium chloride. Formation of silver chloride and sodium nitrate formation is possible. How this equation is balanced, let us see. Okay, silver nitrate, sodium chloride, exchange of ions are possible. It is converted into silver chloride and sodium nitrate. Let us represent this equation also. What we are taking? We are taking silver nitrate on treating with sodium chloride. Product will be sodium nitrate and another will be silver chloride. This is the possible reaction. When silver nitrate taken, it is the solid substance. Added to water, it becomes aqueous solution. Sodium chloride is the solid substance. Added to water, it becomes aqueous solution. Sodium nitrate generated within the water, hence you can say it is a liquid. Silver chloride will be precipitated at the bottom, means it is insoluble in water. Downside arrow indicates what? It is the precipitate, PPT. Upside arrow indicates what? Liberation of gas. Within the chemical reaction, you can mention these signs in order to represent what kind of changes are possible. Here, liberation of hydrogen gas denoted with upside arrow. Precipitation of substance at the bottom denoted with downside arrow. Downside arrow represent it is the precipitated product during the reaction. Silver nitrate, is it balanced? 1 Ag, 1 Ag. Nitrate, nitrate. Na, Na. Cl, Cl. So entire equation is balanced, and you can represent the equation whether substances released are absorbed in the reaction by using this. So this is also completed. Now let us move on to silver chloride. Upon sunlight reaction, it is converted into silver metal and chlorine gas. This is called decomposition reaction. On light treatment, means by irradiating silver chloride when placed in sunlight, what happens? It is converted into metallic silver and chlorine gas. Initially, substance is solid. After the reaction, after the decomposition, it converted into one solid substance and another gaseous substance. This is another transformation we can see where solid can be dissociated into one solid and one gas also. There is a possibility, right? So another is when we are taking gaseous carbon dioxide and liquid water, on treating with sunlight in the presence of chlorophyll, it is a well-known, most important parameter for survival of all living organisms on the earth. The process called photosynthesis. The products generated are glucose and oxygen, right? Now let us see how can we write the balanced equation of photosynthesis. This is the most interesting equation what we can observe. Let us see how can we write balanced equation of photosynthesis here. Photosynthesis is represented as, one second please. Photosynthesis is represented as how can we represent photosynthesis? Possible by taking carbon dioxide and treated with water in the presence of sunlight and by using chlorophyll, green color pigment of the plant, which is the magnesium complex compound, there is a formation of C6H12O6 and liberation of essential organism for the survival of living organisms called oxygen. Right here, in order to balance the equation, this is a very important, interesting equation which carried in the photosynthesis. Photosynthesis is nothing but conversion of simpler molecules into food materials by the process called photosynthesis in the presence of sunlight. Right. Here, 6 carbons are generated within the reaction. That's why we have to take 6 carbon dioxide. 12 hydrogens are produced. That's why in order to get 12 hydrogens, let us take 6 H2O. Right. Then let us see whether equation balanced or not. 6 carbons are there. 6 carbons are there. Oxygens are 12 plus 6. 12 plus 6, total oxygens are 18. Here 6 oxygens are there. 6 oxygens are there. In the second compound 2. 6 plus 2 only 8 are there. We have to get 12. Let us see. Here also 6 let us introduce. It becomes 6 plus 12. 6 plus 12. 18 oxygens are there. Okay. 6 carbons. How many hydrogens? 12 hydrogens. 18 oxygens are there in the starting materials and the products. This is about the balanced equation. Now, what is the physical state of carbon dioxide? Carbon dioxide is the gaseous substance. Water is the liquid substance. C6H12O6 is the solid substance. Oxygen is the gaseous substance. Gas evolved in the reaction denoted with upper arrow. Gas is liberated in the reaction denoted with upper arrow. And here carbon dioxide plus water gives rise to this is called glucose, which is the carbohydrate, and liberation of oxygen molecule is possible. This is the entire balanced equation. I'm writing one more time. 6CO2 solid plus 6H2O liquid. Here reaction conditions mentioned on the arrow. We are irradiating with sunlight. We are irradiating with chlorophyll. Chlorophyll is the sensitizer, photosensitizer, which used to absorb the sunlight, and that sunlight is given to the reactants. Hence it is called sensitizer. C6H12O6 plus 6H2O is formed. In this is called solid, this is called gas, this is called glucose, and this is called oxygen, which is liberated out, right? So entire equation is in balanced state now. This is about photosynthesis. Now let us move on to chemical equation. How can we interpret whether the equation is in balanced form or not? How can we predict balanced equation or not? The chemical equation gives the information about reactants and the products in their symbols, in their formulas. How many reactants are there? How many products are there? We can analyze. And what are the reactants ratio? What the product ratio? How many reactants are combining? How many products are formed? That ratio is also given by chemical equation. Unified mass is also used for representation of chemical equation. What is the mass of starting material? What is the mass of product formed in this reaction can be predicted. The masses are expressed in grams. It also gives the ratio, molar ratio of reactants and products. In both the sides, you can go with gram molecular weight of reactants and products. In that way also it will be represented. If gases evolved, we have to denote with the upper arrow. If precipitated, denoted with downward arrow. Then volume and calculate the volumes, gas liberated given condition, temperature, pressure using molar mass and molar volume relationship. Mass and volume relationship, it is possible to measure if both different terms are there like solids and liquids. In that way, it is possible to get their molar ratio. Now, another point is using molar mass Avogadro number, we can calculate number of molecules, atoms which are participating in the equation. Avogadro number is constant for number of molecules. So, and using molar mass and Avogadro number, it is possible to balance the equation. Let us go with mass-mass relation, mass volume, volume volume, mass volume number relationship. Let us explain aluminium plus Fe2O3, formation of Al2O3 plus Fe. Here, their physical state also represented like solid, 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 and solid. All the substances are in solid state. It is called a mass-mass relation because all are in solid forms only. Aluminium atomic weight is 27. How many aluminium atoms are there? 2 aluminium. That's why 2 can be multiplied with 27 because atomic mass of aluminium is 27 and 2 aluminium atoms are there. Fe2O3, its mass is iron is 56. How many irons are there? 2 irons. 2 into 56 plus how many oxygens are there? 3. Oxygen atomic mass is 16. Right? 2 into 27 plus 2 into 56 plus 3 into 16. This is the molar mass of this Fe2O3. Now, what is the product? 2 into 27 because aluminum is 27. How many? 2 aluminiums are there. Plus, how many oxygen? 3. What is the atomic number of oxygen? 16. 2 into 27 plus 3 into 16 plus how many irons are there? 2. 2 into atomic weight of iron will be 56 units. Unified mass 2 into 56. So if we get all these, 54 unified mass of aluminium are reacting, then 160 unified mass of Fe2O3, 102 unified mass of Al2O3 formed, and 112 of iron formed. Means 2 moles of aluminium, 1 mole of iron oxide, 1 mole of aluminium oxide, 2 moles of iron formation is possible. This is the representation in the form of moles. Means 2 moles are represented here. 1 mole. If it is not there, nothing is there, you can assume it is 1. Nothing is there, 1. 2 is there, it is 2. So 2 moles, 1 mole, 1 mole, 2 moles. Okay, so this is about the entire representation. Even in the form of grams, you can represent like 54 grams of aluminium, 160 grams of Fe2O3, 102 grams of Al2O3, and 112 grams of iron can be combined, right? So this is about the simple representation of molar ratios from reactants to products. Hope everybody enjoyed this lesson, and I think it will be very clear to you. So it will be helpful for your 10th class effective preparation. So thank you very much for your patient listening. Thanks a lot.